Hello everybody, Dr. Metzger here. We're going to talk about procedural content generation. So this is a few of the topics we're going to go over today are what is procedural content generation, what's some of the historical and current uses of procedural content generation, desirable properties, taxonomy of different aspects of PCG, and some metaphors. So let's begin by talking about what is procedural content generation. If we had to define it, we could say that it's the algorithmic creation of game content with limited or indirect user input. And it has been developed and used for a number of reasons. Some of those include saving time and cost. So you are making a game and you don't have enough time to generate all the content in it, so that's a reason for using it. Increasing replayability, so maybe you'd like the game to be fresh in some way every time the game is started. Maybe you want the game to adapt to the player while they're playing it. So if they're a expert player, they get harder challenges. If they're a beginner player, they get easier challenges. Maybe we want to assist designers in making a game. Making games is very technical work, and a game designer might not have the technical abilities, but they might have a vision for something they would like to create. And another reason is to study creativity in game design. So maybe we'd like to figure out what makes PCG so useful. And it has seen some limited use in commercial games since the 1980s, but it hasn't taken over the world per se, although I think it has increased in popularity in the last decade. And part of the reason why that hasn't been the case is because there's aspects that needs to be fast, it has to be reliable, controllable, expressive, and creative. And those are many different dimensions there that make it a very difficult problem to actually solve in practice. Now, a key term here when we're talking about procedural content generation is content. All right, so these are things that we see in a game like levels, maps, game rules, textures, stories, items, quests, music, all different kinds of things, content. And the idea behind procedural is that we would like it to be an algorithm that makes it. So we have some procedure that generates content. And so generation has to do with, that we're dealing with, well, I guess procedural and generation kind of go together, right? We're dealing with computer procedures, algorithms that create stuff. All right, so historically, one of the first games to use it is a game called Elite in 1984. It's not the first game. We're going to talk about Rogue in a second. But this is a game by David Braben and Ian Bell, and it was created for the Acorn computer. And essentially what they had is 8 different galaxies, and each of those galaxies had 256 planets. Now, we're talking 1984. The amount of computer memory available for most gamers was not a significant amount. So having all these galaxies, having all these planets would require them to have to generate the content when the game started. Now, they could have made the game so that all of the galaxies, the algorithm would just generate a brand new galaxy every single time. However, they didn't want people to think, oh, they're just randomly generating everything. Because when we think of the idea of like, oh yeah, it's just random stuff, then we kind of get the idea, well, maybe it's not very good. Just because you're rolling dice doesn't mean that every dice roll is a good roll. And another aspect to this is that the designers also wanted to selectively remove galaxies that had rude things. For example, one of the galaxies, because it generates random names for the planets, had a planet named Ars, for example. And so they're like, well, that would be a rude planet name. So they intentionally chose to regenerate a new seed for a galaxy. So that's some of the design choices that went into this particular game. And it's notable because of the fact that they used procedural generation to generate the entire galaxy for that particular game. So The next game, of course, one of the most famous ones is Rogue. And this was created in 1980 by Michael Toy, Glenn Wickman, and a number of other people. And the idea is to seek the amulet of Yendor at the bottom of the dungeon. And so there's, dozens of dungeons. You have to go all the way to the bottom. Random fact, Yendor is actually Rodney spelled backwards. And so they were just having a little bit of fun there, I think. But there are some elements to Rogue that are key things that you would see in modern games. And so we use the term roguelike to mean games that basically have descended from this original game called Rogue. So some of those elements include turn-based gameplay, and that means that when you move around the dungeon, you make one turn at a time, and then permadeath, which means that if you were to die, it makes sure that the player has to think about what they're going to do. You can't just be reckless and expect to live. So you have to, it forces the player to make meaningful choices. The other elements is all the levels, all the monsters, all the treasures are using procedural content generation. Of course, there's a pattern you're going to expect to see. Some levels will have certain monsters. I think it kind of prioritizes. As you get lower and lower, you see more dangerous creatures. And Rogue inspired a few notable descendants, namely Hack in 1982 and Mariah in 1983. And both those games became the basis for the very popular NetHack game and Angband, which is two popular roguelikes. Now, there are, of course, more. There's a whole tree. You could study roguelikes and look at the whole tree. Many games, indie games, are actually roguelikes. One of the most popular games that was inspired by Rogue and Angband was Diablo. And these are some of the modern games that utilize procedural content generation. Dwarf Fortress is a notable... it doesn't necessarily look the best to a player because they're expecting sprites and all sorts of fancy graphics. But that is a game that uses very significant types of procedural content generation to generate backstories and histories and a huge world around these dwarves that kind of work in these mines and stuff. Diablo is a very popular game that started off as a turn-based game originally, and the creator, actually, when he was working on it, was had decided he wasn't going to do pure turn-based. He was going to set a timer on it. Well, he set the timer on, and it was initially he put his initial value, and what happened when he turned the game on is that instead of 10 moves. One move every second or so. It was like 10 moves in the 1 second, and he basically saw a creature kind of walk around a corridor and go into a kitchen and perform some action on another creature, and he was like, whoa, that's cool. So basically that spawned the real-time, I guess you hack and slash type gameplay. Spore is a game where players can use procedural generation to generate all different kinds of new creatures or worlds to travel through. Minecraft is kind of uses procedural content generation to generate levels and all sorts of things. Probably the most popular game on the planet, it seems, right now. Civilization 4 uses it to generate all different kinds of elements. Spelunky generates random caves, and Tiny Wings as well is another game that uses procedural terrain and texture generation. So it gives the game a different look every time it is played again. So a question, though, is it appealing, though, right? The games vary from Dwarf Fortress, which is, of course, a text-based game on its output. Not too many people find that visually appealing. However, a lot of players enjoy the game because of its depth. So there's different kinds of ways you can define appealing, all right? So just because a game uses PCG, that doesn't necessarily mean that you're going to recognize that when you see it. Okay, so there's a number of visions for PCG, all right? First of all, there's Unsolved Problems. So can we generate multi-level, multi-content procedural content generation? Can you generate practically the whole game, in other words? Or can you use PCG to actually design the game itself? Or can you use PCG to even generate the whole game? You've never seen this game before, all the content's generated and so on. And so these are unsolved because for the first one, multi-level, multi-content PCG, you might know the game engine, you might know the rules that are going to govern the game, but can the content that you generate actually have both quality and consistency? In other words, does it look like all those elements belong inside that particular game? Or for game design, the idea here is that if you were to take out all of the PCG elements of the game, would it be unrecognizable? In other words, is the procedural content generation so embedded in the game that you wouldn't even know it was the same game if you just took them out? And lastly, right, complete games. How do you actually create games that have rules, reward structures, levels, characters, the whole thing without even using any kind of, just basically a click of a button, all right? So these are unsolved problems because doing all of these requires that you understand this whole paradigm and all the different facets, which we're going to kind of dig in here. All right, so desirable properties. So we want procedural content generation. All right, so visions for, we can see we want it to do stuff. So what do we want it to do? So generally there's trade-offs, all right? Just like any optimization problem, you normally have to pick one over the other, right? Speed versus quality. You can have it fast, or you can have it slow, right? And then that could normally ties into quality. Or is it reliable? In other words, does it generate solutions that actually work versus having the variation that you'd like to see in the game, right? So just because you have a random level generator for, say, a dungeon crawler or something like that, that doesn't mean that every level is going to feel unique after you've been inside of it for a few levels. If it's like, oh, this is all predictable. Going back to the game Rogue, for example, the pattern for the Rogue dungeons essentially is, let's just divide the screen into a 3x3 grid, and this is grid 1, 2, 3, 4, 5, 6, 7, 8, 9, and then what we'll do is we'll set each box to be a random width and height inside, and then we decide whether it's connected to the neighbor or not. And so if you were going to look at Rogue in terms of that expressiveness, we can see that after a while the player's not going. About the only thing that they're going to know basically that, well, every level is basically this 3x3 grid, so you know more or less where everything is. Okay, and if you don't find a door on the right hand side, say of this box here, you know you can't get to the middle, and so on. Okay, so that's expressivity and diversity versus reliability. So we know that with the original Rogue game, it's very reliable, but as far as being in a completely different environment every single time you go up or down, that of course is not really the case. So speed is, does this take milliseconds or months? All right, so this can depend on really what you need. So if this is something in game, it probably needs to take milliseconds because the player is going to be expecting to go. All right. However, if you're designing something, maybe it's okay for something to take months. If you write a tool that's really heavily interested in making sure that there's a lot of quality in there. Reliability. So do the results actually work? So just because you throw a random number generator at something doesn't mean that the game will work in the way that it's intended. Maybe it makes the game a level that's impossible to beat, or it makes a level too difficult for a beginner to play. Okay, and you always have that aspect of garbage in, garbage out. If you just throw random white noise into a problem, typically what happens is you see that noise show up in the generation part. So Knowing how to use noise in a meaningful way is extremely important for somebody who wants to use procedural content generation. And then we have controllability. So what can you customize? For instance, in the original Rogue game, you might be able to customize how the maximum number of corridors that are allowed, so that you're forced to have certain rooms that are not connected to each other. You might be able to control what's the range of the size of the rooms, okay? But if you don't have that, but maybe you can't adjust the shape of the room, for example. So Rogue, they're all square rooms, but you can't control the shape of the rooms. Okay, expressivity and diversity. So how do you blend between, I like to call this senseless and sensible. All right, so senseless means when you look at the level, it's like, this doesn't look realistic at all. For example, if you were to generate say a rural village for a role-playing game, that's kind of set in medieval England or something, and everything looks like it really could fit in Manhattan, where everything is like on grids and lines, then you might think, well, this doesn't look sensible, right? Okay. On the other hand, you'd like to generate lots of things. One technique is to use, say, 3D models of different shapes and then try to blend them together. So, but if you were to mix like an airplane and a sailboat, maybe the shape that comes out is not realistic. But maybe you're trying to generate, versus if you were trying to generate different airplane designs and you just blended airplane shapes. Okay, so that might be sensible, and so those are things that you have to think about. Now, creativity and believability. So this is an aspect of when the player sees this, is it going to look handmade? In other words, when they play with it, is this going to feel like a lot of effort went into it? Okay, so that's something that that's another desirable property. Okay, so taking a look at desirable properties, let's look at a different taxonomy of PCG dimensions. So in this paper by Tigalius and others, he has it's called search-based procedural content generation, and it was kind of the start of how do you define the different dimensions of how you approach procedural content generation. Okay, so one of those is do you generate content generation online or offline? So if online means the player's playing the game at the same time that you're generating the content. Offline means that you might allow the player to use the offline tool, like Spore has an offline editor, for instance. Okay, another example is the game Left 4 Dead, which is a first-person shooter that gives a dynamic experience. All right, other games like Little Big Planet, I mentioned Spore already have content editors, so you can kind of generate some new stuff. The other thing is, the other dimension is necessary versus optional. In other words, does the procedural content generation generate all of the necessary things? Like, for example, if you're playing Super Mario, does it have all the reward items included, or are they optional elements? Okay, so in other words, do you generate enough things that the player doesn't need them to finish the level, versus generating the items that need to be used in the level? Okay, that's a dimension. So maybe you're using your procedural content generation to generate optional stuff, like, oh, we'll put some treasure here, we'll put some treasure there, and some treasure there, and then the designer will put all the required out. So if you need a key to get through a certain door, then maybe the designer puts that in there. So that's a dimension of control. Another one is degree and dimensions of control. So, for example, if you use allow the player to put a random seed. So Minecraft allows you to put a random seed in there, and then you can generate. You know that the level that it generates is going to be the same every single time. Okay, so that's an element of can you get repeatability? All right, stochastic versus deterministic. So this element basically means that if you're given the same starting point and method parameters, you get the same output. Okay, so for example, we showed that game Elite earlier. They have 8 different galaxies. You know that if you were to pick one of the 8, that you're going to get the exact same one. So it's not going to be an unpredictable experience. Okay. Another thing is constructive versus generate and test. So in other words, constructive means you can generate everything in one pass, versus generate it, have some players test it out, make sure that it works before you send it out. Okay, so you might want to, or you might even have the content generation test to see if it's a viable solution. Okay, so there's that element. Another thing that I haven't mentioned on here is generic versus adaptive. So that means that for some games, is the game adapting to what the player is doing in real time, versus just kind of having some regular variation. For example, if you're doing a roguelike dungeon crawler, do you just generate a range of monsters, from like, if you're in the beginning of the game, they're like, easy to intermediate, and then when you get to the game at the end, it's like moderately hard to extremely hard, right? So you can control the range depending on certain circumstances. Okay. And lastly, automatic generation versus mixed authorship. So this is kind of getting at, does the designer have any ability to control what comes out, right? So if this is so for example, if the author were to draw a pattern for what he wanted or what she wanted for her level to look like, and then the PCG element will generate something that looks based on that characteristic. So for example, if you draw a circle, do you get levels that look circular? Or if you draw a square, do you get levels that look squarish? Okay, that's kind of an example of automatic generation versus mixed generation. Now, so these are different elements. Your PCG is going to lie somewhere in these different dimensions, okay? So there'll be blends. So if it's an offline tool, it's not an online tool. If it's generating optional elements, it's not generating necessary elements. If it's generating deterministic levels, then it's not generating random levels, okay? And so because of these are dimensions, then you can kind of blend between the two. So if you're designing PCG, you might want to consider this gives you an element of, what am I trying to make? So maybe I'm trying to make an online tool that generates optional components, that gives the player certain dimensions of control, and every single time it's going to be different, and it's going to generate in one pass, and the player can provide an input that generates a characteristic about the level. Okay, so that's an idea of using the dimensions. So there's different, that's a taxonomy of dimensions, but we can also look at different metaphors. And so, we took a look at a procedural content generation system, and a system basically is a generic term for any piece of software that does PCG. Okay, so in this paper, Design Metaphors for Procedural Content Generation in Games, there are 4 metaphors. One's tools, materials, designers, and domain experts. So when you create the system, it's going to utilize an element of one or more of these metaphors. For example, if you're generating a tool, then you're basically writing a PCG system that gives the designer some enhanced capability. All right, so maybe it's not designed to be a gameplay element, it's designed to just help the designer out, right? So you're making a 2-dimensional game as a single person designer, and you'd like to generate 60 levels before you publish it. So maybe he uses a tool, or she uses a tool to generate levels, and then they can look through the results and pick the ones that they like, so they can kind of curate something. Okay, a material allows a designer to work in a new medium. Okay, so this particular kind of maybe you're not a good tree designer, you can't make 3D models for trees, but you'd like to put trees in your software that you didn't have to design from scratch. So tools like SpeedTree allows you to you can make trees that look pretty decently real, and they all look different from each other, but you don't have to be an expert in modeling 3D trees. Okay, so that allows, it's a PCG tool that allows you to work in a new medium. The other one is a designer. Okay, a procedural content designer is going to have less interaction with a human designer, but the idea is we want it to design content all its own. Okay, and so one of the key challenges for that is that it has to not only generate the content in the game, but rules for the game itself. Okay, so this is helping you design games, not just a tool that generates content, but a tool that generates systems that generate rules and mechanics. Okay, and then lastly, a domain expert is a procedural content system that uses knowledge to critique or improve designs. All right, for example, it might have, and these are, keep in mind, you have to program these rules in there. You have to program this knowledge into the system, generally speaking. But you could have it look over, so let's talk about a hypothetical tool that critiques Super Mario levels. It might take a look at a designer's levels and use it to say, well, you don't have enough rhythm, so there's not enough jumping up here and then running over here and then more jumping and then more running. That might be something that can critique levels. You're like, oh, okay, I can see where my level might not be as much fun in this area. Okay, so critiquing. Or maybe it's improving a design. So maybe you give it a pattern to follow, and then it uses that knowledge about creating, say, dungeons or whatever you're going to create to improve an existing design that you've created. Okay, so to close out today, right? So PCG, procedural content generation. So it's algorithmic creation of game content with limited or indirect user input. And the user can be a player, or the user could be the game designer, or an artist, or a programmer. Okay, and it's been around since the 1980s, but it still has limited use in games, and partially because there's that balance between whether the game just feels like somebody just threw a random bunch of stuff together, or whether it was like handcrafted. So there's limited use in games because of that, and that's because there's many unsolved problems and aspirations. We all like the idea of, can the computer generate experiences for us that we've never seen before and that are fun and exciting? Okay, there's also an element that we would like, some properties, desirable properties. We want it to be fast, we want it to be reliable, controllable, expressive, and creative. And the thing is that you generally can have one or the other, but not everything all at once. Okay, but in the ideal world, we'd like it to have those properties. Now, we also took a look at various dimensions. So dimensions are things like, is it online or offline, stochastic, deterministic? Okay, it's a complex mixture of all those. And lastly, talked about different metaphors. So there's tools, things that a designer can use to make content for their game, materials, tools that allow the game designer to work in different mediums, such as creating random trees, designers, tools that actually make games or game mechanics, and domain experts. So these help critique or improve designs. All right, so quiz for you. So what reason would you, as a game designer, use procedural content generation? Okay, and if you were going to use it, so what steps would you take to integrate it into your game design? All right, what dimension and metaphor is most applicable in your situation? And then lastly, please take a look at the article by Tegelius or Khaled and summarize that in the Discord channel. Okay, well, hope you have fun playing around with procedural content generation or thinking about it, and I look forward to talking with you later. So, adios.